Hi Professor, I want to go through assignment 64 with you on a screen video. Alright, so I just jumped to the point that we've been talking about here on 64. We're trying to determine if x and y is going to be independent, and from there I took from the notebooks the definitions of whether or not something is going to be independent. You interjected here on the continuous random variable, then do we say that all x and y and join xy? So what I assume that you mean by this is going to be that since it's a continuous random variable, that we're taking a graph on a continuous manner, not a discrete manner. So in fact, you would have to say all xy to incorporate everything on the graph from the point of the smallest point, call it 0 to infinity, on a continuous function, on a continuous graph. As far as on this, I have gone through a couple different models here. I'm trying to show what's going on here. If j PDF of x is going to be equal to the PDF of x times the PDF of y, then they're independent. If that equation is not equal, if j PDF of x of y is not equal to j PDF of x times j PDF of y, then they're not independent. I fully understand this concept. I'm having trouble with the live math side of it and showing you here if j PDF of x is going to be equal to the PDF of x times PDF of y. I try to do PDF of x here on the top and PDF of y here on the bottom, and then down here try and take my j PDF of x times PDF of y. That's what I was trying to do by doing this, but it's incorrect certainly. So my apologies on that. I understand the concept. I understand what we're doing here. It's just an algebraic live math computational adjustment that I'm not sure how to make. But I'm going through the correct formula here and trying to do that for you and show you my knowledge of what's going on and what's being asked of me. From here, we were going into determining volume measures of probability of y is going to be greater than or equal to of 2x. So what we want to say here is on a function, what's the probability that y is going to be bigger than the 2x here. From here, what we're looking to do here is take your PDF of y greater than 2x and solve an integral from 0, or double integral rather, from 0 to 2, and then the innermost integral is going to be from 2x to 1 of the j PDF of x dy dx. The integrate the y first because the x is in the bounds of the integral that we're then trying to solve here when we're doing a double integral, in the innermost one being from 2x to 1 j PDF of x dy dx.